All right, properties of normal distribution. So for another class that I have, it was 7.1, but math doesn't change. So it's 13.4 for this class. Properties of normal distribution. This is our normal distribution curve, our bell-shaped curve. We'll talk more about that as we progress forward. Let's do some background work to make sure we're all right. A probability distribution or density function is an equation used to compute probabilities of continuous random variables. All right, it must satisfy the following two properties. The total area under the graph must equal to 1, and that's going to be key for us later. We're talking about all the area under this curve is equal to 1. And then the height of the graph must be greater than or equal to 0 for all possible values. In other words, all your values or results will be positive. All right, give you a chance to write that down. All right. A continuous random variable is normally distributed. Once again, it goes back to our bell-shaped curve. Has a normal probability distribution if its relative frequency histogram has a shape of the normal curve. So I'll scroll up in a second. Once again, give you a chance to write this stuff down. All right, so this is our normal curve. You have your mean that's in the middle. And then also they point out these inflection points. I forgot whether WebAssign asked you about them or not. It may not. But inflection points, and when you add a standard deviation and then subtract the standard deviation away from the mean. And inflection points is just when the curvature changes, when it goes from being concave up to concave down. All right, of course, if I scroll up and you still copying, let me know. So properties of the normal density curve. So the normal curve is symmetric about the mean. So when you look at your curve, oh, that's not it. You have your mean in the middle. What's going on the right side of the mean is also going on the left side of the mean. So it's mean by symmetric about the mean. Mean is in the middle, and whatever's going on the right is reflected on the left side of your mean. Number two, your mean, median, and mode has a single peak and highest point, and they're equal. All right. 3, we already mentioned, it has inflection points. When you add a standard deviation, subtract the standard deviation from your mean. And number 4, also mentioned that the area under the curve is equal to 1. So that means if you know one side, if you know 70% of data is to the left of your value, then that means 30% will be to the right of it. So that's all that means, is that everything under the curve is equal to 1. So if you know one part, then you know the other part. All right, 5, we mentioned that one already as well. Area under the curve to the right of the mean equals half, and the same goes for to the left of the mean. So when we say the mean is in the middle, it is a slap dab in the middle. Whatever's going on to the right is going on to the left. 50% of your data is to the right of it, 50% of your data is to the left of your mean. Once again, these are just foundational things. Once again, these are just foundational things. Properties: as x increases, the graph approaches but never reaches the horizontal axis, which is 0. Same thing goes on for x decreasing or going to the left side. So you're talking about right here. So you leave that little space right there. Just represents that it doesn't ever touch the horizontal axis, or it doesn't ever get to 0. It may get very close to it, but it never gets there. All right, then that 7th point, which is what we're going to use in the next example, the empirical rule. We'll still copy 6. Okay. So approximately 68% of the area under the curve is within one standard deviation of your mean. Or in other words, 68% of the data. 85%, 95% of the data is within 2 standard deviations of the mean, and then 99.7% of your data is within 3 standard deviations of the mean. A little diagram for this relationship, but give you a chance to write that down before we go there. All right. I see my Going up too far. All right. So they'll go to diagram that goes along with those three statements. So these percentages, according to the empirical rule, these percentages up here will not change. They are fixed. They will always be the same. But the numbers down here will change according to the data values that we have, and you'll see what I mean in a second. But that's the diagram. Once again, those percentages are fixed. The mean is in the middle. To the right of your mean is 50% of your data. To the left is 50% of your data. All those data values add up to 100%. All those add up to 100%. Notice if you go out one standard deviation, add a standard deviation, subtract a standard deviation, that's 68% of your data. Add a standard deviation, subtract another standard deviation. In other words, go 2 standard deviations out. You add these together, that'll be 95% of your data. Then go out 3 standard deviations, that'll be 99.7% of your data. And like I said, add up all of it will give you 100%. All right, before we put this to work, any questions? Anybody still copying the diagram? All right, so just making sure we know how to calculate this and work with it. It says the birth weights of full-term babies are normally distributed with mean of 3,400, standard deviation of 505. So we're just gonna fill in the empirical rule chart just to make sure we're cool with it and how you would calculate it. The next one we do, we actually have questions that pertain to what we're doing. I just want to make sure we're okay with the process. All right. So according to the empirical rule, you have your mean in the middle, that's 3,400. Then to the right, we have 3 values, adding a standard deviation once, add a standard deviation twice, add a standard deviation 3 times to get the right side of your mean. Then to get the left side of your mean, you're going to subtract the standard deviation 3 times. All right, and our standard deviation is 505. So in the purple right here, we have our right side of our mean. 3,400 plus that 505 is 3,905. Add 505 again will be 4,410. Add 505 one more time, that'll be 4,915. So that's how you get the right side of your mean. Right. Make sure we're okay with that. All right, to get the left side, we will subtract 505 3 times. So 3,400 minus 505, 2,895. Minus 505 again, that's 2,390. Then minus 505 one more time, that's 1,885. All right. Questions? Any questions? All right. So then you would just put those back. Well, not put them back. We'll put them in the chart. You'll see right here. Put them in there accordingly: 3,905, 4,410, 4,915, and then going to the left: 2,895, 2,390, 1,885. And once again, those percentages up there are fixed. And in the next one, you'll see how those percentages will help us to determine certain things or come to certain outcomes. All right. Questions before we do another example? All right, so we're good to go to the next problem. Everybody good? All right. You know what? That's the wrong set of notes. Take it back. There we go. All right, so let's look at doing that again, but this time we have some questions that we're going to answer. So a survey of 1,000 U.S. gas stations found that the price charged for a gallon of regular gas could be closely approximated by a normal distribution with the mean of $3.10 and standard deviation of 18 cents. How many stations charge? And the first one between 2.74 and 3.46 for a gallon of regular gas. Give you a chance to write that down. All right. So let's look at taking our information, and this is once again using the empirical rule. We're going to take our standard deviation and our mean. They gave that to us, 3.10 and 18 cents. Find the right side of our empirical rule. So we take 3.10, add 18 cents to it 3 times. So that'd be $3.28, $3.46, $3.64. Then to find the left side, we subtract 18 cents each time. Well, 3 times, I'll say it like that. 292, 274, 256.
Hello?
Hello?
Can you hear me?
I can hear you
Oh,
now.
okay.
Yeah.
Okay. Are you guys working on anything right now?
Yeah, we're doing a lecture.
Are you guys doing a new lecture?
No, 13.4.
Okay. Just making sure.
All right.
I already saw your lecture that you sent out,
Mm-hmm.
but I do have some questions, some homework questions. So after when you're done with the lecture, I do have some questions about the
Okay.
homework.
All right.
Yeah.
All right. So any questions on right side, left side? Everybody good? All right, so let me erase this. So here's the chart. We have our 310 in the middle. Then to the right, there's 328, 346, 364. To the left, 292, 274, and 256. All right, so for A, we want to know the percentage, and we look at the red statement that I have down here, the percentage of gas stations between 274 and 346. So 274 is right here, 346 is right here. So we're going to add these percentages together that are in between those two values, and that would be 95%. Now the question asks for the number of gas stations, not the percentage. So we will multiply the percentage to the total number of gas stations. Total number of gas stations was 1,000. So we take that 0.95, multiply to 1,000, that's 950. So 950 of the gas stations out of that 1,000 charged between those two numbers, or those two prices. All right, questions on that first one? All right, so B, how many charge less than $3.28? So we look at that red statement there. We're going to add all percentages that are less than or to the left of. Less than and left of are synonymous, just like greater than and to the right of would be synonymous. So we're looking at 328. So let's go back here. 328 is right here. So we're going to add up all of the percentages that are to the left of 328. So we're not talking about these values down bottom, we're talking about the percentages. So that's why I have 0.15, 2.35, 13.5, 34, 34. Adding those together will give us 84%. And then just like before, we multiply the percentage to the total number of gas stations. So that's 0.84 times 1,000. That'll be 840 of those gas stations. Any questions? Any questions? All right, last one like this before we go to the next topic. More than $3.46. So more than is same thing as greater than, which means to the right of. So we're going to add all of the percentages that are to the right of that 346. If you were to go back to your chart, 346, oh, that's 364, 346 is here. So you're talking to the right of, that's just the 235 and the 0.15. So that's what we did here for C. So 2.35 plus 2.15 is 2.5%. And once again, we multiply that percentage to the total number of gas stations, which was 1,000. So convert 2.5% to a decimal, which is 2.025 times 1,000 be 25 gas stations charge more than $3.46. All right, questions before we go to Z-scores? All right. So the standard normal distribution are going to be our Z-scores. So the Z-scores represents the distance the data value is from the mean in terms of standard deviation. So before using the empirical rule, we looked at going 1 standard deviation out, 2 standard deviation out, or 3 standard deviations out. The Z-scores allows you to be more precise, and you can compare your data values by going, 1.23 standard deviations or 0.96 standard deviations out. So if we talk about what your z-scores mean, if you have a positive 1.23, that means your data value is 1.23 standard deviations above the mean because it's positive. If it's negative 0.78, the data value is 0.78 standard deviations below the mean, which is below because it's negative. All right. So next thing that's important about your z-scores is the z-score chart. So you have to be able to read it. So if we have a z-score, we calculate our z-score to be 1.23. So you notice how I have the chart, and we're about to go to it in a second. 1.2 is going to be over here on this left column. The rightmost digit, which is the 3, will be on the top row. And then you'll see where they meet in the chart. So let me see. I should have it up already. Yep. So you have a positive side, negative side for the chart that I gave you guys. And the chart that I gave you is a little easier to read, to me anyway, than the chart that the book gives you. So 1.2 is right here. 3 is right here. So that represents 1.23 as a z-score. And you see where they meet would be the chart value. And that's 0.8907. All right, so that's how you read your chart. So what does that mean for us? Oh, also, didn't point this out when I was on the chart. This part right here just lets us know that whatever value we pull from the chart represents what's to the left of that z-score. So we'll see how that applies to us in a second. And that's what I was saying right here. The chart value given is always less than. So that 1.23 is going to represent the data value. You'll see when we do our conversion. In this case, that 0.8907, which as a percentage is 89.07%, it's just 89.07% of the data is going to be less than this data value. If I want to know greater than, I will subtract it from 1. And that means subtracting that from 1 gives you 0.1093. So that means 10.93% of the data is greater than this value. So remember, we talked about everything under the curve is equal to 1. So if I know one side, remember, if I know this side, which is 0.8907, that means that this side subtracted from 1 will be 0.1093. So that's how that works. From this chart, you will always know the left side. In order to get the right side, you have to subtract it from 1. And the right side is greater than. Any questions? Questions? All right, can I scroll up? All right, so to calculate our z-scores, we will take the data value that they give us, subtract it from the mean, or subtract the mean from it, and then divide it by the standard deviation. So that's our formula, data value minus the mean divided by the standard deviation. All right, so here's our example. A soda machine dispenses soda into 12-ounce cups. Tests show that the actual amount of soda dispensed is normally distributed with a mean of 11.5 ounces and standard deviation of 0.2 ounces. The first question is, what percent of cups will receive less than 11.25 ounces of soda? All right. So first thing we'll do is convert 11.25 to a z-score. That's what we did right here. Our mean is 11.5, standard deviation is 0.2. That was given to us by the problem. It gives the data value of 11.25. So we use our formula right here. That'll be 11.25 minus 11.5 divided by 0.2, which will be negative 1.25. And also take note here that you always round your z-score to 2 decimal places. All right, so now you go to the chart, you go get the chart value, and I'll show you guys that one more time. All right, so where's my negative? All right, here we go. So we're looking for negative 1.25. So we got negative 1.2 right here, 5 up here. Where they meet will be our chart value. And so you see that's 0.1056. And you're probably reading the chart. And so that's how we got that value right there, 0.1056. So statements in red, we are looking for less than, and the chart gives us the less than. So that's what we would go ahead and use the chart value. I'm pointing that out because it's going to matter in the next statement. So we're always looking, the chart will always give us less than. And remember, this problem was looking for less than, so we can use the chart value. And so that's 10.56% of the cups will receive less than 11.25 ounces of ounces of soda. All right, next one, what percent of cups will receive more than 11.8 ounces of soda? So first move, just like before, convert the data value that you're doing your comparison to, the more than 11.8. The data value in question, convert that to a z-score. So you do 11.8 minus 11.5 over the 0.2, mean and standard deviation. That gives us 1.50. All right, go to the chart. It's 1.5 on that left column. Zero zeros on the top row. Remember that zero is right here. That gives us 0.9332. That's the value we're getting from the chart. All right, so the chart gives less than, but we need more than. So that means we're going to subtract the chart value from 1. So remember what they asked for was what percent of cups will receive more than 11.8, but the chart once again gives us less than. So we take the chart value, subtract it from 1, which is 0.0668. So that's 6.68% of the cups will receive more than 11.8 ounces. All right. Questions before we look at C? Make sure we're all right. All right, last one. What percentage of cups will receive between 11.2 ounces and 11.55 ounces of soda? So this time they give us 2 data values, and we want to know the amount of data or amount of, in this case, cups, percent of cups will be between those 2 values. Mean and standard deviation is still the same, 11.5 and then 0.2. But then I found the z-score for 11.2, which is negative 1.50. Then you find the z-score for 11.55, which is 0.25. So you do your data value minus the mean divided by the standard deviation. All right, so we want to know the amount of data is between both of these z-scores. Go to the chart, get the 2 chart values, the chart value for each z-score. Then to find between, we'll subtract the chart values from each other. So we took the 0.5987 and subtract 0.0668 to get 0.5319. All right, so it's 53.19, 53.19% of the cups will receive between 11.2 ounces, 11.55 ounces. And if I'm not mistaken, looking at WeberSign wants it to the thousands place. So you would just take your answer, round it to 3 decimal places. You know, so WeberSign was asking for the thousands place. But just pay attention to the directions, and you should be fine. All right, problems with that before we sum it all up. All right. So while looking at when dealing with your z-scores, there are only 3 scenarios: less than, more than, between. Less than, you're going to use the chart value that's given. More than, you're going to subtract the chart value from 1, and then between you subtract the two chart values from each other. So you calculate your z-score, go to the z-score chart, you're going to get a chart value. There are going to be three key phrases one of three key phrases that they use. If they ask you about less than, you use the chart value. If they ask you about more than or greater than, then you will subtract that chart value from 1. Then if they ask you about between, amount of information, amount of data, percentage of data that's between, you subtract the two chart values from each other. All right, questions. On anything written? All right. So that is it for our sections of new information or new data, new things to talk about. So, if you don't have your questions today, then always feel free to bring one next class. From this point forward, we'll be reviewing. All right, I see your hand, sir. I'll get you in a second. So from this point forward, we'll be reviewing and getting ready for this final. I'll make sure everything should be posted. That test 13, I think is posted. I don't know, I'll take a look. But everything should be posted. And your final exam is on May 12th at 3:30. Somebody asked about, what if you had a one that conflicts, a final that conflicts with another teacher? That's not supposed to happen if you haven't taken final exams at Norfolk State before. There's going to be a block scheduling for the final exam week. I'm going to send you a copy of that sometime today. I meant to do it yesterday, didn't get a chance to do so. That each teacher is supposed to abide by as far as block scheduling. So if your class meet at a certain time, then your final exam is supposed to fit into that block. And so that's where that time come from. I didn't pick May 12th at 3:30. That's what Norfolk State has dictated our final exam is supposed to be on. Mr. Penner.
So the like in that last problem, you have a median of 11.5, but in standard normal distribution, when you're doing your z-scores, that's based on a 0 mean, right? So that I'm getting confused with how those two correlate.
Okay, so yeah, that's good. So now your actual mean is 11.5, like you said, but now when you convert it to a z-score, it's going to be 0. Because remember the z-score formula is your data value minus the mean, which is 11.5, divided by the standard deviation, which is 0.2. Now, if I put 11.5 right there, that's going to be 11.5 minus 11.5 over 0.2, which is going to be 0 over 0.2, which is your 0. So it's just saying that once you convert your mean to a z-score, it'll be 0. Did that make sense?
Yeah, that helps a little bit. Yeah.
Yeah, because when you look at your distribution, and when everything's converted to z-scores, you're looking at it with ones, twos, yeah. So the reason why this is 0 as a z-score is because you put it in the z-score formula, and then it'll turn into 0. But its actual data value would be 11.5. It's just that you got to convert it to a z-score in order to see that it's actually 0.
Okay, thank you.
Mm-hmm.
I had a question. It was about because I think I sent the email to you about the quantitative reasonings test. If I could redo it, I don't know if the email went through yet.
I don't remember because I know we talked about it, and I asked you to send me an email to remind me. I didn't see an email that reminded me. That's why I hadn't even thought about it. So,
okay.
so I completely forgot because I knew I was going to.
No,
That's why
okay.
I asked you to remind me. So yeah, I'll try to do that. I'll write a note to myself.
Okay.
Yeah. All right.
Yeah, I still have time to do the other assignments on WebAssign.
Yep, they should still be open. Now, if you're talking about though chapter 7 and chapter 9, you need to send a request for that because those are not open, but everything else is still open.
Okay.
All right.
Professor.
Yes, sir.
What was that the date for 511? What is due that date, sir?
Oh, that wasn't for you guys. That was
Okay,
for
check.
my other class. Yeah.
But 512 is more or less when our final should be posted,
Yep.
correct?
Yep. This is
Check.
your final exam. So what you would do, and I'm going to send you guys instructions and everything. Now, that is going to be your proctored test because all the other ones, you guys kind of skated because I let you guys just take those, at your leisure. Now, this one we don't have that option, so you will have to come in, not come into class, but come into the Zoom. Enable your cameras, make sure you bring ID. And then once you do that, I'll give you the password, and then you'll be able to knock the test out, and you will leave your Zoom cameras on and everything like that. So, it's supposed to be solidifying that you're actually taking the test and stuff like that. So I'll send instructions on that as well on what will be expected of you on that date.
Thank you, Professor.
Not a problem, not a problem. All right. Anybody else on just general class things before I know we have one of your classmates who had a question on a couple problems.
And this is going to be on the 13.5 13.4 or just all 13 for the
Wait,
lecture?
you
The
talking about
final.
the final exam?
Yeah.
A final exam would be on everything, like from the
Okay.
beginning, yep, up to this point.
And we're getting like the pre-test for the final exam, correct?
Yeah, it should have already been posted. I'll check to make sure, but you talking about
Okay.
the final exam review?
Yeah.
Yeah, it should be up there, but if not, I'm gonna go in and make sure everything's up there for you guys to be straight. Yeah.
Okay.
All right. So I know Miss Regine has some questions. If you want to stay back, see what her questions are, feel free to do so. If not, I will see you guys on the next class.
What's 511 for?
That was for another class.
Oh, that was for no class. Okay.
Yep.
I have questions on 13.4 lecture.
Yep.
Well, I did question 1, and it says use the empirical rule to answer each question. So I have my mask on. So during
Okay.
a week, an overnight delivery company found that the weights of its particle were normally distributed. Let me split my screen. With mean of 20 ounces and a standard deviation of 5 ounces. And then said, what percent of particles weighted between 10 ounces and 25 ounces? And it says round your answer to 1 decimal place. Okay, so I got the answer, but I didn't know how I got the answer. I followed like the video that it said you can read it, watch it, and I followed the whole thing. So it literally just told me how to do it. Like I followed step by step, but it's just I don't know how the way you taught it, like using the graph and everything. I don't know how to do that.
Okay.
It just did the like 10 minus 25, and then that's what it did. So
So
I don't really know how to do it.
yeah, that's not a problem. So your mean is in the middle. That's 20.
Okay.
And then to get to your next 3 values, you're gonna add 5 because you're adding your standard deviation. So you're gonna add. I want to make sure my stuff's in share right. Yep. Okay. So you add 5 to both sides. So plus 5 is 25, 30, 35. So that's gonna be the right side of your mean. Left side of your mean, you're gonna subtract 5.
20,
So it's
25.
gonna be 15, 10, 5.
15, 10. Okay. Oh, and then it says like the other one, that's A, and then B say what percent of percent of the particles weigh more than 35. So it shows A and B.
Yeah, we'll get the B. So I just want to make sure we're straight on A. We'll use the same diagram, so we'll be fine. So now in your percentages, these percentages are always the same. So it's 34, 34, 13.5, 2.35, 0.15.
That's 12. That's 13.5.
Yeah, I'm just writing small and sloppy.
Oh, okay, my bad. Critical writing, my bad.
So
2.35. And that's a 0.05?
all right, hold on. Let me see which one you're talking
Oh,
about.
that's 0.15. Oh, okay.
Yeah, well, okay. So over here, 0.15. Yeah.
Okay.
So it should be 34%, 13.5%, 2.35, and then 0.15.
Okay.
And then those same data values on the left side. All right. So you good so far?
Yes. Yes,
All
I
right.
am.
So once again, just making sure we're clear. These values, these bottom values are going to change according to your information. Those percentages will never change. So in the middle is always your mean. Then you add a standard deviation 3 times. And then to the left, you subtract the standard deviation 3 times from the mean.
So they're both 3 times on each side.
Exactly. Uh-huh.
But on the okay, so the left side you subtract, and the right side you plus. Okay.
So now the data values in question, we have 10 and 30. Oh, not 30, 25. So you add the data values, percentages, excuse me, in between those two data values. So 13.5, 34, 34. That's going to be what, 80, 81.5.
Okay, that's my answer. That's what I got, 81.5. I just didn't know how to, it was confusing. I just didn't understand how to.
Yeah, it's all good. And then B, that was what?
It says, what percent of the particles weigh more than 35 ounces?
Yeah, so more than 35. So you go to your 35, which is here, and then more than 35 is just the 0.15. We're talking about more than, would be to the right of it.
Oh, okay. I see how you got that answer. I got that answer too. I got that right. I just like, how did they get that?
Yep.
What they did was that they did 35 subtract 20, and then they divided by 5, and then you have 15 over 5, and then that equals 3. And then they said after that they went straight to 0.5. And I'm like, wait, how you get from 3 to 0.5?
That's what they did in the book?
That's what the video showed me. And I'm like,
Oh.
understand it. I was
Yeah.
like, went online, websites. I was even asking my friend how to do it, and they didn't
Yeah.
even know I got that answer.
Yeah,
So I was,
the book, and that's why I gave you a different chart, because this book does things a little more complicated than what it has to be sometimes. And so,
yeah.
like, even the chart that they give you for Z-scores is a little more complicated than the one I gave you. That's why I gave it to you guys.
Okay. Well, that's one question down. Okay, so I have like 6 more, but I don't want to keep you waiting. Because I don't understand some of them. Like, for instance, question 2, it says find the area to the nearest 1,000 of the standard normal distribution between given z-score z equal 1 and z equal 1.9. And the thing is that the answer is 0.130. I got that right. I mean, yeah, I got that right, but I don't know how they I didn't know how they did it. Because the watch is completely different. Like, I was like, wait, how did they get that answer? Like, doesn't make any sense. Because what they did is that it says z equals 1 is 0.341. And then 1.9 is 0.47. And so they did 0.4471 equal 0.341, and then that comes to equal 0.130. So I'm like, how'd you get the answer though? Like, how does that come to be? How is the equal number 1 come all the way to this other decimal number? Like, I was just confused.
So let me say this, and I see you, Mr. Penner. Let me ask her this question real quick. So now, I just want to
Oh,
make
your
sure.
volume went down. I think that was me. Let me boost the volume. Sorry, hold on, okay, I'm sorry. I just gotta boost this volume. I couldn't hear you. Can you hear me?
I can hear you fine.
Oh.
No, your volume's down.
Volume down?
Can you hear me? I can hear Regine, but I can barely hear you.
Yeah, that's why I had my volume boosted. I boosted. Okay.
Hold on 1 second. That didn't help out at all, right?
No, but I can come right back in. Maybe it's, I don't know. My
But
computer
no,
messed up.
Mr. Penner said it's not just me. I mean, not just you. Really, it's pretty much me. Hold on 1 second.
Okay.
It might be that earphone mic.
Mm.
Does that help?
Yes.
That's better. How about you, Mr. Penner? Better?
That's a little better, but there is echo on the line. That's weird.
I think that's
Oh, let me tell you.
yeah, she turned me up real loud on her end. All right, so Mr. Penner, how does that work?
Yeah, you sound fine now.
Okay, it must have been maybe these are done for. Maybe those old ones are done. All right, so so Miss Regine, I just want to make sure I'm clear. Now, Mr. Penner, let me stop. Was that why you were raising your hand?
Well, what I was saying is when you go to the chart, what they did was you go to the chart, but because I think it's and this confused me too, was because it's to the right of 0, or there's some verbiage that they used. And so because it deals with 0, they actually subtract 0.5. So the value they get is like 9703. You subtract 0.5 from that, which is 0, Z value 0. And then that gives you the 0.44 or whatever. But I was like, why did they do that? And I know it has to do with to the right and to the left, but that confused me. That's why I'm staying on the line.
Right. And that's why I'm trying to get you guys to use the chart that I gave you and not necessarily lean toward what the book did, because the book is telling you a different way because they're using a different chart. And if you ultimately you'll get the same answer. It's just that my way is a little less involved than their way. And so that's why I'm trying to kind of emphasize, use my chart that I gave you, because it's less trying to minus 50 and all the stuff like that. Because I know where they're coming from, but it's according to the chart that they gave. So let me make sure I'm looking at the right problem. We're talking about between, right? Yep. So we have 1.00 and 1.9. Now, if it's just 1, then remember all your z-scores have to go to 2 decimal places. So that's why we have 1.00. So we go to the chart. I'm talking about the chart that I have in both cases. So, oh, that's the negative. Okay, positive. All right. So 1.00, we got 1.0 here, 0 right here. They meet at 0.8413. So that's the chart value that we're going to use. 0.8413. So make sure we're okay with that z-score value. Okay. Then we do the same thing for that 1.90. Okay. So there's 1.9 right here, 0 right here, and that's 0.9713. All right. So before we go any further, are we all right with how we got those values? All right, Ms. Regine, you good on that?
Okay, so I don't understand how you got the 0. Is that for because you went 2 over to the right? Is that why you used that?
Well, you gave me the values of 1 and 1.9, right?
Yes, I did.
So your z-scores are always going to be to 2 decimal places. So if you have 1, then that means you should be doing 1.00. And if you have 1.9, it should be 1.90. All right, so your z-scores are always going to be to 2 decimal places. So 1.0 is right here, and then the 0 is right here, and when they meet, is at this 0.8413. And then,
Okay.
okay, that's straight?
Yeah, for the 1.0, and then when you do for 1.90, you did.
Same thing, just 1.9 is down here and 0 is up here. And then they meet at 0.9713.
Okay. So, I thought you would do it for 0.90 for at the top. Like you did 0, 0. You stuck with 0, 0. Okay.
Well, yeah, so that top, that top row right here represents that last digit. So if it was 1.93, then I would go over to the 3 here. You see what I mean? Or if it was 1.96, my 1.9 is right here, but I would go to 6 over here. See what I mean?
Okay, I see what you mean now. I get that. I get it now.
Gotcha. Okay. So now we go back to, let me go back to my notes. So these were the chart values that we pulled. Now, if you remember, I told you there were 3 scenarios that you're going to have. Either it's going to be less than, more than, or between. So now we're dealing with between. So since it's between, we're going to take both of these values and subtract them from each other. So between means you're always going to subtract your chart values. That should be 700, just making sure though. Yep, so 0.1300. And your web assign, from what I've seen, wants your answer to the thousandth place. So you would just round it to the thousandth place. So they want 3 decimal values from what I've seen instead of the 4.
So that makes sense. They didn't show none of that. They didn't do none of that. I don't know how they got those answers. Woo,
Right.
thank you.
Not a problem. All right.
I don't know if he has any other questions, but I have a couple more, a little bit more, but I don't want to. So my other question is find the area to the nearest 1,000 of the indicator region of the standard normal distribution. In the region where Z is, I think that's less than 1.3. Yeah. No, sorry, more than. That was another problem. I was doing something else. More than.
All right. All right, so I'll try not to do your answer for you. So I'll go 1.5. All right. So this is greater than or more than. Remember, if it's just 1.5, then we're looking at 1.50 because we need 2 decimal places. And you go to your chart. It's probably this one. Nah, I picked the wrong one. All right. So 1.50, 1.5 is right here. 0 is up here. So that meets right here at 0.9332. So chart value 0.9332. Now, remember, whatever the chart value is, that always represents, for the chart that I gave you now, not talking about the books chart, that always represents less than, but you want more than. So you're going to take that chart value and subtract it from 1. That'd be 0.0668. And if they want it to the thousand place, 0.067.
Wait, you put the 1 there.
You talking about right here?
Yeah, the 1.
Yeah.
What was the 1?
So whenever you want to do more than, you're going to subtract your chart value from 1. That's the process that you will take on.
Is that for everything, or is that just for
Every
this?
time they ask you about more than. See, there are 3 key phrases. Matter of fact, where is it at? Here you go, right here. There are 3 key phrases that you're going to be dealing with. They're either going to ask you about less than, ask you about more than, or ask you about between. So if it's less than, you will just use the chart value that they give you. If it's more than, which is what we just finished doing, you're going to subtract that chart value from 1. And then if it's between, like we did in the previous one, we subtract the 2 chart values from each other. So those are your 3
Oh, okay.
scenarios.
I took a picture of it.
Okay. Yeah, but those are your 3 scenarios.
Okay. And wondering how 1.3 is. Okay. So then after that, you subtract. So for my 1.3, you subtract it by 0.0968.
1.3. Oh, wrong one. So I see 0.9032.
0.0968, and then
Yep.
you subtract 1 by that. 1 subtract that, and then
Wait,
you'll get your answer.
hold on. So was it negative 1.3 or positive 1.3?
It's positive. There's 2 tables in here. Okay, never mind.
Yeah. So make sure you're on the positive.
Yeah, so yeah, it's 0.9032. And then so then you do 1, subtract that. Okay. So and then I'll get my answer. Okay. Whew. I think I know how to do the next question, the next one, 2.71, because then I have to go to 2.7, and then I'll do the 0, right? And I'll just get the same 1, and I subtract it by 1. Or do I subtract?
Well, now, does it ask you for more than?
It asks me for, well, it doesn't, I don't see that it's asking me. Oh, I'm at the wrongest one. Hold on. Oh, no, it's asking me for less than.
Okay, so now if it's less than, you just use the chart value that they give you.
Oh, right, chart value. Okay, so I'll have to do that one with you. 0.2. Can we skip all the way to 5?
What you mean? When you say skip all the way to 5?
Yeah, because I know how to do 4. Because once I know how to do this type of question, I can do the other ones because I know how to
Can you
do.
go to problem 5?
Yeah, problem 5. Yeah.
Okay, yeah, I didn't know what you're talking about.
My bad. Because all they have is just 7 questions. It's just that I'm confused. But can we do 5? Yeah, because I don't need to do 4 if I know how to do 3. That's not difficult. So 5 said find the z-score to the nearest hundredth that satisfies the given condition, and it's 0.2 square onto the area of the standard normal distribution is to the right of z.
1, 2, 1, 2, hold on.
Okay.
0.
3. This is 4.
Yep. Okay, so the one I see, where's my notes? What do I have sharing right now? Okay, notes. Okay, so this one, I think this is the only one like that. Let me see. Yeah. Yeah, this is the only one like that. Okay, so this one gives you the area and asks you to find the z-score that corresponds to that. So, where are my notes?
Where's my calculator at?
So I have 0.212. This actually, when they say the area,
Mm-hmm.
what do they call it? Yeah, the area. They calling that the area of the thing. That's the same thing as the chart value. So what they did in this problem was they gave you the chart value and they want you to find the z-score that corresponds to it. So you go actually into the chart and find the value that's closest to this and see what z-score corresponds to it.
Okay, let me write that now. Maybe we'll remember that. Mm-hmm.
All right, so this one right here is the closest one.
So I got 0.200, and so you got 0. What is it?
Mine was 2.12. And so that corresponds to negative 0.80.
So mine corresponds with the 0.2, so 0, so mine is 0.59. I'm trying to get this.
What you say you got yours? Yours was what? Point what?
I have 0.200.
200. Okay, so let me go back to the chart. Okay.
So wouldn't mine be 0.5793?
All right, so you said 200, trying to find C2, 5. Yeah, that's 201. Trying to find the closest one to that.
Oh, so I'm wrong. I don't know.
That is 209, 206, 203. So if you round it up to 8, that's 198. So really, your value should be this one, the 2. See how we have
you're in the
negative?
Oh, you're in the negative?
Yeah, because that you see how you see 2.2005?
Yeah.
Yeah, that would be the closest one to the 0.200. And then that
Oh,
corresponds.
I thought it's when when the number is a negative, then you go to the negative.
Well, that's when your z-score, because remember all these values inside the chart aren't going to be negative. All of them are going to be positive. But remember, we're inside the chart and we want to go and find a z-score that corresponds to this value inside the chart.
So how'd you, I'm confused, like I'm really confused with how you got 0.04 as the one. I thought it would be 0.00 still. And then go to 0.2. Oh, okay, it is 0.2. So you go to 0.2.
Right, you're looking for 0.2 inside of the chart, inside of here.
Right.
So this is the closest thing right here. We have 0.2005. So then you say what z-score corresponds to that. So you go up here and over here, and that's going to be negative 0.84. So you got to use both pieces over here.
Negative 8.4. I don't see negative 8.4. Is that me? Am I right?
So do you see 8 over here?
I don't see 8 over here. All I see is 0 all the way from 1, 2, 3, 4.
So on this left side right here, the left column.
Mm-hmm.
You say you don't see an 8 right there, negative 0.8?
Mm-mm.
What you see?
Oh, I have a, oh wait. I guess because was saying negative 8.4. You're saying negative 0.8?
I'm
What are you?
saying that when you look at this will correspond to the z-score of negative 0.84.
Oh.
Because it's a 0.8 on the left column and a 4 on the top row. In other words, when you...
That's why you picked 0.2005.
So now that's the value that's closest to the 0.200 that you were looking for. So what was on top of here is 0.04. And then what was over here was 0.8, negative 0.8.
Oh, see, okay, I get what you're saying now. Oh, so when this answer comes up, they just want me to find which one's closest.
Yeah.
I was confused. I was so confused. I was like, how can I find this answer? Okay, I understand that one. I understand that. Okay. And then that's how I got, that's how I know this is the answer for 0.205. Oh, okay. Didn't know that. Okay. So I have 2 more questions and then I'm done. Just 2 more.
Just 2 more. You passed your time.
Yeah, just 2 more. Oh, it said it was.
Say what?
It said it was wrong.
What, the negative 0.84?
Oh, I'm supposed to put that in. Okay. Right.
Yeah, the negative 0.84.
And you added those together.
Well,
Wait, okay, yeah.
You brought them together, the negative 0.8 and the 4.
Okay, so I was wrong for that part. I see how you got the answer though.
Okay.
48. And then you do negative 0.8 plus 0.04. And then that equals negative 0.84. Okay, and so my next question after that is negative. I'm sorry, I'm just putting this in so I know.
Now I have to get ready to go to my next class though. So do you want to hold it for next class and knock them 2 out, or do you want to set up another time to meet?
Yeah, we can set up another time.
Okay.
Also, it's still saying it's wrong. Like it's not negative 0.84.
All right, let me see what you talking about here. Let me. What happened to my thing? All right, so because mine say 212 to the.
And mine says 0.200 square units of the area.
Oh, you know what? Try positive. Did you try
Positive?
0.84?
No. Oh, I should have just did that, I think.
Try positive 0.84. I didn't see to the right of Z, so let's see if it's supposed to be positive before I go.
Oh, it's right. It's right.
Yeah, that's because it says to the right.
Yeah,
that was my fault. I didn't see to the right of Z.
Right, and I'll see if I can do. I'm gonna do these other 2 last questions and see if I can do it. But if I can't, I'll like tell you about them and how.
Okay.
Yeah.
Okay, so now.
Thank you. I appreciate it.
Yeah, so in both of those cases, you got to convert those values to z-scores. You know, the 224 minus 180 over the 38. You know, this formula right here. Hold up. Oh.
I'll take a picture.
Oh, there we go. So the first thing you have to do is.
For those 2 problems.
Yeah, for the last 2 problems,
Use that formula.
You have to follow this procedure right here. Yeah.
Okay.
Convert
I took the
to
picture.
Z-score, then go to the chart, and then you know, according to the keywords that we were talking about here, you know. So yeah. So try it out. Let me know if you need to meet, or you can wait for the next class. It's up to you.
Okay. Well, thank you. I appreciate it.
All right.
Have a blessed day.
All right, you do the same.
Bye.